Hello everyone. In this video we will learn about finding the integrals of the functions by using substitution. We have already learned finding the integrals of the functions where they are given in the standard forms. But suppose the functions are not given in the standard form, then we have to reduce them into the standard form by using substitution, and we will find out integrals of them. What type of questions, what type of problems can be there? Let's learn that. Suppose we have a function y which is f of gx. Then we know if we differentiate this, the dy by dx will be equal to f dash gx into g dash x. We know chain rule is to be applied for this. It means in case we want to find out the integral of f dash gx into g dash x with respect to x, that will be equal to f of gx. This is the thing we have to understand, that if it is not a function of x, but in place of x some other function has been given, then we have to use the substitution method and we have to find out the integral by substitution. Let's understand it through some example. Like we have integration of cos of x square plus 1 into 2x. We see here gx is x square plus 1 and we are finding g dash x is 2x. What about fx and f dash x? If we say that f dash of gx is equal to cos of x square plus 1, can we say that f of gx is equal to sine of x square plus 1? And hence what we can say about this? This is again the same thing, f dash of gx into g dash x dx. So here we will find this is equal to f of gx plus c. And f of gx here we are finding is sine of x square plus 1 plus c. The same problem we will do by substitution now. The question was here cos of x square plus 1 into 2x. Now what we find, x square plus 1 is replacing x here. It means this is gx. So we can convert this x square plus 1 as t. So we are writing suppose or let x square plus 1 equal to t, then this particular function will become cos of t into 2x dx. But what about 2x dx? If we differentiate this with respect to t, we will find here 2x into dx upon dt equal to 1. It means we can write that 2x dx is equal to dt. So this 2x dx can be written as dt here. Now it is a function of t in the standard form, and we know integral of cos t is sin t. So we can write this as sin t plus c. Put the value of t here, we will find this is sine of x square plus 1 plus c. So this is the way we can make use of substitution in the problems of integral also, where we have to convert the given function to the standard form and then find out the integral. When we find the integral by using substitution, generally we have three forms of problems. What are those? The first problem we may have is integration of f of ax plus b. Second form may be integration of f dash x into fx, and the third form may be it is f dash x upon fx dx. To discuss the problem of first type, integration of f of ax plus b dx, what we substitute? We substitute here t for ax plus b. So we write let ax plus b equal to t. When we differentiate this with respect to t, we find a into dx by dt plus 0 is equal to 1, which gives us a into dx is equal to dt, or we can write dx is equal to 1 upon a dt. So we can write here, this will be f of t into 1 upon a into dt. This 1 upon a is a constant. So we can write here 1 upon a integration of ft dt. Suppose the integration of ft is f of t, then this will be 1 upon a into ft plus c. And we can substitute the value of t here. This is 1 upon a into f of ax plus b plus c. To understand this with one example, let's take it. Suppose we have integration of sine of 3x plus 2. We can write here 3x plus 2 equal to t. When we differentiate, we are getting 3 dx is equal to dt, or we get dx is equal to dt upon 3. So we can write this as 1 upon 3 sine t dt or not. And we know the integration of sine t is minus cos t. So this will be 1 upon 3 minus cos t plus c. Substituting the value of t, we get minus 1 upon 3 cos of 3x plus 2 plus c, which is the answer. Generally, what we can do in this type of problems, without taking this as t also, we can solve this type of problems where we have the linear functions of x. And what we find here, the coefficient of x comes as the multiplication in reciprocal. Like here, coefficient of x is 3, so it comes as 1 upon 3, and you can write the integration of sine t. In the second forms, that is integration of fx into f dash x dx, we can take this fx as t. So we write fx is equal to t. Then when we differentiate, we will find f dash x dx is equal to dt, and we can write this as t into dt. So this becomes t square upon 2 plus c, and we can substitute the value, that is 1 upon 2 fx square plus c. Let's discuss one example here. Suppose it is log x whole square upon x dx. We know here if fx is log x, then d by dx of log x is 1 upon x. So we can substitute here log x as t, and then when we differentiate this, we get 1 upon x dx is equal to dt. So this can be converted into dt, and we can write this as t square into dt, which gives us t cube upon 3 plus c, because this is the standard form of the integration. And when we substitute the value of t, we get 1 upon 3 log x whole cube plus c. This is the answer. In the third form, we find it is integral of f dash x upon fx dx. We can substitute t for fx. So we can write let fx is equal to t, which gives us f dash x dx is equal to dt. So we get here dt upon t, and we know the integral of 1 upon t is log of t. So this is equal to log of t plus c. Substitute the value of t. So this comes as log of fx plus c. This is the answer. Let's take one example on this also. Suppose the example is find the integral of 2x plus 5 upon x square plus 5x minus 3. If we substitute t for this, we can write let x square plus 5x minus 3 equal to t. And when we differentiate this with respect to t, we are getting 2x plus 5 dx is equal to dt. So it becomes dt upon t, which is equal to log of t. We substitute the value of t. This comes as log of x square plus 5x minus 3. So this is the way we can find the integral of such type of functions. You all know when we were writing the fundamental formulae of integration, we didn't write the integral of tan x, cot x, sec x and cosec x. That we can find by using the method of substitution. The integral of tan x, to find this, what we can do, we can write this as sin x upon cos x. And now we know the derivative of cos x is sin x, so we can write here let cos x is equal to t, and then differentiating we get minus sin x dx is equal to dt, or sin x dx is equal to minus dt. Substitute here, this is minus dt upon t, which gives us minus log of t plus c. Substituting the value of t, we get minus log of cos x plus c. This is the integral of tan x. We can also write this as log of cos x power minus 1 plus c, using the identity log of m power n is equal to n log of m. Then this becomes log of 1 upon cos x, and we can write this as log of sec x. So this becomes the second formula for integral of tan x. That is, one is minus log of cos x plus c and another is log of sec x plus c. Similarly, using the substitution, we can find the integral of cot x. Cot x can be written as cos x upon sin x, and this will come as log of sin x. To find the integral of sec x, we have to use a particular method for this, because there is nothing as the derivative of this in multiplication. So we have to multiply and divide a particular function here, which brings it to the substitution form. And what is that? We can multiply and divide it by sec x plus tan x. Why we have multiplied this sec x plus tan x only? Because if we substitute here sec x plus tan x as t, when we differentiate this with respect to t, we are knowing the derivative of sec x is sec x into tan x, and that of tan x is sec square x dx is equal to dt. If we take sec x common, we are getting sec x into tan x plus sec x dx equal to dt, and this is what we have in the numerator now. What we get here, this is dt and this is t, which is equal to log of t plus c. Substituting the value of t, we get log of sec x plus tan x plus c. This is the first formula for integral of sec x. If we simplify it further, can we write this as log of 1 upon cos x plus sin x upon cos x plus c? If we take the LCM cos x here, we are getting log of 1 plus sin x upon cos x. And we know the identity we can write this 1 plus sin x as the square of cos x by 2 plus sin x by 2. Cos x can be written as cos square x by 2 minus sin square x by 2. If we make the factors of it, one of the factor cos x by 2 plus sin x by 2 will be cancelled out here. And then we will be left with log of cos x by 2 plus sin x by 2 upon cos x by 2 minus sin x by 2. If we divide the numerator and denominator here by cos x by 2, will we get here this as log of 1 plus 10x by 2 upon 1 minus 10x by 2? Because we know cos x by 2 will cancel and sin x by 2 upon cos x by 2 is 10x by 2. We also know the formula for this. This is an identity. 1 plus 10x by 2 upon 1 minus 10x by 2 can be written as tangent of pi by 4 plus x by 2. So this becomes the second formula for the integral of sec x. To find the integral of cosec x, we have to multiply and divide this also by a function that may be cosec x minus cot x or cosec x plus cot x. If we multiply by cosec x minus cot x, will we get here cosec x into cosec x minus cot x upon cosec x minus cot x. If we take this as t, let cosec x minus cot x is equal to t. Differentiate this, we are getting the derivative of cosec x minus cosec x into cot x. And that of cot x is minus cosec square x dx is equal to dt. If we simplify this and take cosec x common, are we getting here minus cot x plus cosec x dx is equal to dt? And this is what we have here in the numerator. This was the reason that we are multiplying it by cosec x minus cot x. So this becomes dt upon t, which is equal to log of t. Substitute the value of t, we are getting log of cosec x minus cot x. This becomes the first formula for the integration of cosec x, that is log of cosec x minus cot x plus c. If we use the trigonometry here to simplify it further, are we getting this as log of 1 upon sin x minus cos x upon sin x? Take the LCM sin x, we are getting log of 1 minus cos x upon sin x. And we know the trigonometrical identity 1 minus cos x can be written as 2 sin square x by 2. And sin x can be written as 2 sin x by 2 into cos x by 2. This 2 and 2 cancel. This sin x by 2 cancels the square. Are we getting here log of 10x by 2 plus c? This is the second formula for integral of cosec x. We can also do it like this, that this can be written as, if we use this, can we convert it as log of cosec x minus cot x into cosec x plus cot x and divide it by cosec x plus cot x. This will be cosec square x minus cot square x, which will be equal to 1. And this is cosec x plus cot x. This can be used as the third formula for the integral of cosec x. We can also write this as minus log of cosec x plus cot x. One more thing I would like to discuss with you here, in case you have been given any of the problem with the radical powers. It means, like suppose you have been given a question as root of 3x plus 2 dx. And suppose you want to use the substitution, then better is you can substitute here 3x plus 2 equal to t square to avoid the root or the radical power. I will take a particular problem here with the radical powers of x. Suppose the question is 1 upon root x plus cube root of x. Can we write this as 1 upon x power half plus x to the power 1 by 3? In such type of problem, what we can do, we will see the denominators of the powers here, that is 2 and 3. If we see the LCM of 2 and 3, that is 6. So better is, in such type of problem, we can write x as t to the power 6 to avoid the problem of radical powers. When we differentiate this, this will give you dx is equal to 6t power 5 into dt. Then what we can write, this dx is 6t to the power 5 dt, and here x power half, can we write this as t cube? X power 1 by 3, can we write this as t square? And if we take t square common here, this will be 6t5 upon t square common, this is t plus 1. 6 is a constant, we can take it out of the integral, and we can write this as t to the power 5 upon t square into t plus 1. This t square and t to the power 5, if we simplify, the power will be reduced and this will come as t cube upon t plus 1. We see here that the degree of numerator is greater than the degree of denominator. So either we divide the numerator by the denominator, or by other way we can convert this into the mixed form. Here we find it easy to add and subtract 1 to this. Why we are doing it? Because we know the factors of a cube plus b cube. If we use that, will we get a plus b into a square minus ab plus b square minus 1 upon t plus 1. In the first part, t plus 1 and t plus 1 will be cancelled. So we will be left with t square minus t plus 1. And the second part we will have minus 1 upon t plus 1. This has been converted to the standard form, and we can write the integral of each part. This is t cube by 3 minus t square by 2 plus t minus log of t plus 1 plus c. Now we can substitute the values of t here. This will be 6 into t cube, means that will be x to the power half upon 3, minus t square means that is x to the power 1 upon 3 upon 2 here, plus t means x to the power 1 upon 6 minus log of x to the power 1 upon 6 plus 1 plus c, and this is the answer. So like this, you might have seen how to apply the substitution method in different type of problems of integrals. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.